Pre-calculus notes on section 2.4, solving absolute value equations. So in this section, we are going to be solving lots of other types of equations other than polynomial equations, and we're going to start with absolute value equations. Right here at the top, we've got something that gives some simple, obvious rules about absolute value equations. If C is greater than 0, then the absolute value of C is the same as C. If C is less than 0, then the absolute value of C is the opposite of C. So if you have a negative number, so like the absolute value of -4 is equal to -4. That's what that's saying. All right, underneath that is actually the geometric definition of distance, and distance is one of the fundamental ways that we use absolute value. So the distance between 2 points or 2 numbers is the absolute value of their difference, and what that does, you're subtracting, but it really doesn't matter if that is negative or positive, because order doesn't matter in distance. It's always positive. All right, so now what we're going to do is we're going to start solving some absolute value equations. We're going to start off with some very simple ones that are very much like what you did last year in Algebra 2, and then we're going to move to some harder ones. So this one's pretty simple, and the most important thing to remember with absolute value equations is that there are 2 possible solutions. All right, since the absolute value of x is equal to C or negative C, okay, that means what I've got to do is set up 2 separate equations where the stuff inside the absolute value is equal to 5 in this case, or the stuff inside the absolute value is equal to -5. And then you solve 2 different equations. So here I'm going to add 3. And here I'm going to add 3. But there are 2 possible solutions. Two possible solutions. All right, next problem. Okay, you might want to try this on your own. It's very straightforward, just like the last one. Pause the video. I'll do it in just a second. All right, here I have, again, 2 solutions. All right, now, here, this one's more difficult, and what makes it more difficult is that there is an absolute value, a variable inside the absolute value, and then there's another variable that's outside the absolute value. And when we have more complicated absolute value equations like this, we end up with extraneous solutions. Okay, extraneous solutions develop because the rules of algebra take into consideration more than the actual possibilities are. So we always have to check the solutions to make sure that they really work. Okay, with those first few easy problems we didn't, but again, because of the variable both outside and inside, the possibility exists that we could have solutions that don't really work. So here I'm going to take x plus 3, I'm going to set it equal to 4x minus 1, that when I do my separate equation, I've got to do x plus 3 equals the opposite of 4x minus 1. Okay. All right, so here I'm going to subtract x from both sides. I'm going to add 1 to both sides. I'm going to divide 3 on both sides. Okay, here I'm going to distribute the negative. I'm going to add 4x to both sides. Subtract 3 from both sides. Divide 5 on both sides. Okay. All right. So now what I want to do is I want to check my work. Okay, so what I want to do now is plug those solutions back in to the original equation. So I'm going to do the absolute value of 4/3 plus 3 equals 4 times 4/3 minus 1. And I want to see if that's true. I'm not trying to make your life too miserable here. We're checking our answers. We're verifying a solution. So let's just use a calculator to see if this works. So I've got 4/3. Let me move this up. Plus 3 is 4.33333. Okay. 4 times 4/3 minus 1 is 4.33333. So that works. All right. Now I'm going to try the other one. Okay. So I'm going to take the absolute value of -2, this is a negative, 2/5 plus 3 equals 4 times -2/5 minus 1. Bring that calculator back. -2/5 plus 3 equals, right, positive 2.6. Now I'm going to do 4 times -2/5 minus 1 is negative 2.6. So does the first one I did was the one that was inside the absolute value. This right-hand side, or the second thing I did, is not inside the absolute value. And so does 2.6 equal negative 2.6? It does not, which means that this is not a solution. However, the first one was a solution. So it is your responsibility to check for extraneous solutions. All right, this is pre-calculus video on solving absolute value equations part 2. And with this video, I'm going to focus on quadratic. Absolute value. Okay. All right, so here, this is even, oh my God, this is going to be so much work. You're going to love this. Here again, you're going to have to check for extraneous solutions. We're going to first start by setting this making two different equations, setting this equal to a positive one and a negative one. And then in blue, I'll do it again. Okay, that's a negative one. Move that so that you can see it. Okay, that's a negative one. Negative one. All right, I'll make sure that's clear. All right, so we've got all of those methods you learned for solving quadratic equations in section 2.2. Let's see if this is factorable. You know, if it's factorable, that's the easiest method. So I'm going to set this equal to 0 first by subtracting 1 from both sides. Okay, and now I want to look to see, are there factors of negative 6 whose sum is positive 6? Yeah, I doubt that. Okay. Okay, so that's not factorable. I think that the easiest method for solving this is going to be the quadratic formula. So here we go. I've got x. Oh, turn my pen back on. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative 6 plus or minus the square root of 36 plus 24 all over 6. Okay, negative 6 plus or minus the square root of 4 times 15 all over 6, which is negative 6 plus or minus 2 radical 15 all over 6. And a 2 comes out up top and bottom. So I'm going to take a 2 out of this, this, and this. I have negative 3 plus and minus the square root of 15 all over 3. Okay, so that's one possible solution. I am going to take this blue one and copy it to another page. Let's see if this one is factorable. I'm going to add 1 to both sides, which gives me 3x squared plus 6x equals 0. All right, this one looks like it is factorable. So I can GCF a 3x. Set both factors equal to 0. And solve those equations. Okay. I have 4 possible solutions here, and you can see them here. This is 2 solutions because I have the plus and the minus. Here are 2 solutions because I've got 0 and negative 2. I'm going to have to check all of those solutions back in the original absolute value problem. Yep. I'm going to drag this all the way down to the bottom. Okay, so here was my original absolute value problem. Let's see if I can get that calculator back out. All right, so I have this number, negative, I'm going to find out what this is first. This negative 3 plus or minus the square root of 15 all over 3. I'm going to go negative 3 plus the square root of 15. I need to put that all in parentheses. So I go back and say insert parentheses. Divided by 3. Okay, so that equals, now we're dealing with approximations here, and we're only checking our work, so approximations, might be okay. So x is approximately 2.29. Okay. And now I'm going to try the same thing in my calculator, but in this case I'm going to subtract the square root of 15. So I'm going to bring this back up on my screen again and come over here, put my cursor so I can change it to subtract. Oops, that's wrong. That was parentheses. I'm trying to make this a subtract. There we go. Square root of 15. Enter. And that gives me negative 2.29. So let me just jot that down. X is approximately negative 2.29. There's a decimal there. All right, so back to the calculator again. I'm going to now do 3 times 0.29 squared plus 6 times 0.29 minus 1. Now my question is, does that equal to 1? That's what the absolute value equation that we were given said. It's equal to 0.9923. Well, I'm going to say that's pretty darn close to 1. So I am going to say that that solution worked. Again, we truncated 0.29, and so we expect that we've got a rounding error when we plug that back in. All right, now what I'm going to do is I'm going to do the same thing all over again, but I'm going to plug in the negative 2.29 and see if that works. So 3 times negative 2.29 plus 6 times negative 2.29 minus 1. But I do also have a number pretty close to positive 1. All right. So that means that both of those solutions, those irrational solutions, were both correct. Now let's try the whole number solutions that I got from the blue equation. So I have 3 times 0 squared plus 6 times 0 minus 1. That's negative 1. But remember that on the left-hand side of this equal sign, this is inside the absolute value. So the absolute value of negative 1 is positive 1. Okay, so that solution works also. And now I'm going to do 3 times negative 2 squared plus 6 times negative 2 minus 1 is equal to negative 1. And again, we're taking the absolute value of that, and the absolute value of that does equal positive 1. All right. Finally, I think I'm done with this problem, and I've got 4 solutions. Okay. I've got 1, 2, 3, 4 solutions. Right? You do have to check your work. And in this part, we are going to be focusing on the definition of distance, which I gave you back in the very first video in this sequence. So the distance between C and D is the absolute value of C minus. So here's what I'm going to do. I'm just going to use that definition, and I'm going to put the two things that I'm finding the distance between inside absolute value. I'm going to subtract them. So we've got negative 3x subtract negative 2 inside absolute value is 5. Okay, that's the equation. I'm going to solve this equation. I'm going to simplify what's inside the absolute value. Okay. I'm going to write 2 different equations. So I've got negative 3x plus 2 equals 5, and I have negative 3x plus 2 equals negative 5. I'm going to solve both equations. And, okay, so x could be either negative 1 or x could be equal to positive 7/3. Okay. All right, that's it for this video.